Hello, everybody. We're going to get started with the session on auditing. So we're going to have 5 talks of 10 minutes each, and then all the questions are going to be at the end for 10 minutes. Great. Okay, our first talk is going to be a socio-technical audit assessing police use of facial recognition by Ivani Radaya-Dixit.
Can everyone hear me? Okay, perfect. So hi, everyone. My name is Ivani. I'm seeing some friendly faces in the audience, which is cool. And I'm from the Mindur Center for Technology and Democracy, and also a master's student at Stanford. And I'll be talking about my joint paper with Gina Neff on socio-technical auditing. As many of us know, algorithmic systems can perpetuate existing power structures and cause real-world harm. Algorithmic audits are increasingly used to hold people accountable for the algorithms they implement. Audits are powerful tools to help interrogate existing power structures in society. For example, the famous Gender Shades audit revealed how facial analysis algorithms fail to recognize dark-skinned individuals, which points to structures that render Black people, especially Black women, invisible in our society. Algorithmic audits have been used in a variety of domains and have motivated tech policy. Now, although audits have had significant impact, much work remains to integrate ethical and legal evaluation into audits. And this work is challenging. For example, consider whether the use of an algorithm complies with data privacy law or human rights law. This work has to be anchored in specific legal jurisdictions. The same can hold for important ethical principles of fairness, accountability, and transparency. For example, do the developers of an algorithm engage with historically marginalized communities? Or are they held accountable if people are harmed? These questions are highly dependent on the context and type of system being audited. In this paper, we present an external audit that evaluates the ethics and legality of police use of facial recognition in England and Wales. Now, while technical audits evaluate the outputs and technical aspects of an algorithmic system, we consider this to be a socio-technical audit, because we consider both the technical and the human aspects. In this presentation, I'll first talk about our audit and then lead up to our results and conclusion. It's important to note that this audit doesn't greenlight the use of facial recognition, but rather our audit scorecard serves as a tool that outside stakeholders can use to reveal real-world harms. We developed this audit using existing research literature and soliciting input from 35 stakeholders across academia, government, civil society, and police organizations. The audit scorecard is composed of questions that can be scored and that are divided into these 4 sections. The first section of the audit scorecard evaluates how police show their compliance with the law. This section includes questions related to the Human Rights Act, the Data Protection Act, and the Equality Act, as the use of facial recognition engages with the rights protected by these acts. The second section evaluates how reliable facial recognition is in terms of its accuracy. Facial recognition has been shown to perform worse on people of color and other groups, so we consider questions about algorithmic fairness and whether police use robust practices when using the technology. The third section evaluates how facial recognition changes police decisions. This includes questions about the police review of the facial recognition output, questions about preparation and training, and accountability when people are harmed. The fourth section of the audit evaluates the extent to which there is meaningful expertise and oversight over police use of facial recognition. This includes oversight from an ethics body, civil society, and most importantly, the broader community. After developing this audit, we applied it to 3 facial recognition deployments in the UK. First, we examined the live facial recognition deployments by South Wales Police from 2017 to 2019. And these deployments were ruled unlawful in the Bridges court case. Our second case study was of the use of live facial recognition by the London Metropolitan Police from 2016 to 2019. And our third case study, which seems to have snuck down there, was of the South Wales Police deployment of facial recognition using a mobile phone application. And this was a fairly recent deployment from December 2021 to March 2022. After applying the audit to these 3 deployments, we found that all 3 failed to meet the ethical and legal standards that we compiled in the audit. And I'll next talk about the key reasons behind this. First, we found that these deployments may have infringed upon privacy rights, since they may not have been in accordance with the law or necessary in a democratic society as required by human rights law. For example, the South Wales Police used live facial recognition at a peaceful protest, and they also sought to identify innocent individuals who were arrested but not convicted of a crime. This broad scope raises concerns about whether the deployments infringed upon human rights law. Second, we also found that there was a lack of transparent evaluations of discrimination. For example, the London Metropolitan Police didn't publish an evaluation of the racial or gender bias before deploying their technology. Although they conducted an evaluation, they didn't make the results public. And this is especially concerning since their technology had a precision of just 24% during deployments. Now, even if police forces are transparent, they aren't necessarily held accountable for the harms. And this points to our third concern, which is that there is no clear framework to ensure accountability for when people are harmed by the use of facial recognition. Police force documents were also not fully accessible to those with disabilities or provided in immigrant languages. And this can make it hard for certain groups to understand how they are impacted. Finally, we found that the 3 deployments lacked regular oversight from an independent ethics committee and the broader public, especially historically marginalized communities and people with intersectional identities. For example, the oversight body for the South Wales Police deployments consists of police officers, and is a body situated within the police. Now, this raises serious concerns about the independence of the oversight. Now that I've highlighted some of the key issues that we found, I'll next share insights for other researchers who can use our approach when designing their own socio-technical audits. First, all audits are not created equal, and we can intentionally design audits that shift power to impacted communities. In our work, we audited a surveillance system, and surveillance, by its definition, means to watch from above, from a position of power. Our audit reverses this gaze and watches from below by evaluating police use of facial recognition surveillance. Our audit can shift power from those using surveillance to communities impacted by surveillance. Second, making audits context-specific requires us to come down to the local scale. This involves community participation in the design of the audit, as well as considering historical context and legal risks within the particular jurisdiction. For example, we needed to consider how people of color and low-income communities are disproportionately surveilled in the process of designing our audit. Third, one challenge when auditing is having access to necessary information. A lack of access can be a limitation, but it can also be an insight because it exposes what is hidden. For example, in our work, we found that police forces didn't disclose the demographic breakdown of arrests resulting from the use of facial recognition. And this illuminates how power is concentrated in the police. Finally, it's important to consider how an audit will lead to accountability. And we focus on accountability through regulation and public attention. Just 3 months after publishing our audit, an East London Borough Council passed a motion to ban police use of live facial recognition. The councillor who proposed this motion referenced our audit, noting that the motion aligns with our findings. Our results have also been shared publicly through news outlets such as The Guardian, and this can motivate stakeholders in the UK to call for change. To conclude, in this work we demonstrate a practical audit tool that scrutinizes a socio-technical system from the outside. We also provide insights to help other researchers design their own socio-technical audits. And we hope this work contributes to the growth of tools that are being used to scrutinize and challenge how power is distributed in our society. Thank you so much, and feel free to reach out to me via email or Twitter. Thanks.
Next, we're going to be hearing about Navigating the Audit Landscape, a framework for developing transparent and audible XR by Chris Norval.
Okay, thanks. My name is Chris Norval, and today I'll be presenting our paper, Navigating the Audit Landscape, a framework for developing transparent and auditable XR. So XR is an umbrella term for augmented, mixed, and virtual reality technologies, all of which work to blend the physical and virtual environments. And these technologies are growing in popularity, being deployed across a wide range of sectors, including within surgical and healthcare, avionics, military, travel, and countless others. But the nature of XR also raises some fairly interesting challenges from a transparency and accountability perspective, and that is, how can we even begin to foresee and preempt the range of possible ways in which an XR system might be used? How do we make sure that these systems are operating in ways that they should be? And if something does go wrong, how do we disentangle what happened and take steps to prevent it from reoccurring? So these questions, while they're not unique to XR, they raise particular challenges in an XR context, and that's because these technologies and their outcomes are driven by a tight-knit coupling of both physical and virtual environments. As a consequence, it'll often be impossible for developers to predict the range of contexts and scenarios that their XR systems might be used in. And so, with so many degrees of freedom, it can be difficult to put appropriate safeguards in place. Further, these systems can be driven by various data sources, sensors, and variables interacting at runtime to drive the functionality of the XR system itself. And this not only means the system can be complex and opaque and difficult to understand, but there'll be many potential points of failure, including those relating to hardware, software, the physical environment, and even human error. And third, when something does go wrong, the physical nature of XR means that it can directly lead to physical harms, in addition to those more traditionally discussed with regard to algorithmic systems. So things can and do go wrong, and this is something we need to be thinking about. So for example, an XR system might provide incorrect instructions or information to the operator, causing them to take unsafe actions. Or a digital annotation might distract the user or obscure a potential hazard in the physical environment. And in fact, we're already seeing countless news articles and reports linking XR applications to damage, injuries, and in some cases, even death. So in the event that something does go wrong, it will be important to understand why. So this is an example taken from another paper of ours, which summarizes the types of issues and harms that can arise from XR systems. And it argues that more needs to be done to make these technologies auditable. So, as I'm sure we'll hear a lot today, auditability concerns having the ability to reveal and enable some reconstruction of the system's use, its runtime behavior, and the surrounding contexts in which it was being used. This might include information about the technical components which are involved, about the physical or virtual environments, and the broader context that the system was being used in. And in the event that something goes wrong, or if there's simply a need to better understand why an XR system is behaving in the way that it has been, audit information can play a vital role in the review, the scrutiny, and the comprehension of these systems, supporting broader transparency and accountability aims in the process. But what information do we actually capture and how? In another bit of previous work, we demonstrated that capturing technical data, and just technical data, can introduce its own tensions, and it may not always be possible to capture everything, or it may not even be necessary to capture everything. And what might be appropriate in a surgical application, for example, may be entirely different to that within an industrial context. But again, XR systems will often introduce socio-technical concerns above and beyond just technical data capture. And so XR systems will need to be designed, built, instrumented in such a way that they capture and produce the right information. That is, the right information to enable various stakeholders to review, understand, and scrutinize how these systems are operating in practice. But given that there's no one-size-fits-all approach to auditability, it can be difficult for those building the systems to know what to record, when and how to process data, where to store it, and why, for example. So to support the auditability of XR, we created a framework to systematically guide developers through the instrumentation process, determining what information is relevant within their particular contexts, and the various considerations and implications of doing so. So this helps make information about XR systems transparent, much like we've seen in other contexts, including the likes of model cards and fact sheets and data sheets within algorithmic system. Our framework is split into 3 classes, and each of these were derived from and encapsulates our previous findings and those from the literature. So we have the general class, which helps to consider the overall intent of the system, to set the broader context for exploring audit concerns. It helps the person using the framework to identify the various stakeholders involved, the risks that might arise as a result of the system, and the resource constraints, be they technical, financial, or other, that they might face in the process of adding these audit regimes. The second class, the capture class, helps those using the framework to identify the various data sources available for capture across all relevant components and to reflect on the various considerations for capturing each of these data sources of interest. And these include the likes of the granularity and the frequency of data capture and the potential impacts of data capture on the system itself, the sensitivity of the data, and so on. And finally, we have the record class, which concerns the data management and storage of the records being produced. It covers aspects such as whether data is stored locally or transferred off device, and the storage network and security considerations that each of these decisions may raise. Furthermore, it helps those using the framework to consider whether capturing particular bits of information might raise legal or compliance-related obligations. So in all, our framework aims to help systematize the audit process. And naturally, this can be useful for a broad range of stakeholders, including the users of the devices, auditors, regulators, and so on, in understanding the types of data capture and the considerations that might arise in any given scenario. But with this framework, our main focus was with XR developers, given that they'll often be the ones responsible for instrumenting their systems and implementing an audit regime. And so we wanted to put our framework to the test with 20 expert XR developers to see whether the framework could help them to identify more data sources and more audit considerations with the framework above and beyond their current processes for doing so. And what we found was that it did. Using the framework was statistically linked to identifying more data sources and considerations. The participants also reported that they found the framework to be usable, helpful, and that they would likely use the framework again in the future. So in other words, our framework helped support the audit process and support the participants in thinking about auditability and recognizing the importance of their decisions. And finally, during interviews with the participants, we found that the auditability of XR systems doesn't currently seem to receive much consideration, and there was a need for structure and guidance in implementing data capture, and that they appreciated the framework's role in supporting this process. So bringing things together, the auditability of XR is important, and this is an area that warrants attention. XR systems are seeing wider deployment across a range of different use cases and contexts, and the ability to review, scrutinize, and oversee how these systems are operating will play a key role given the range of risks that these technologies can present. Our framework aims to support XR stakeholders in navigating the audit landscape, that is, in determining the types of data capture that might be appropriate and the various considerations and tensions that might arise as a result. And there's also a wide range of other research opportunities this gives raised to, including the potential for technical capture mechanisms. And that's something we've also been thinking about. So we'll be at UbiComp later this year to present Droiditor, which is an open source framework to help an open source tool to help mobile XR developers implement data capture within their systems. But there's much more to be done, including on aspects such as the broader risks of audit data, including issues of privacy and surveillance, security considerations, data usability, stakeholder engagement, and how approaches to XR auditability can fit within broader audit regimes, to name a few. And so what we're hoping to do with this talk is to encourage the FACT community to think about some of these challenges and to help advance this important yet currently under-considered topic. Thank you very much.
Next, we'll hear from Alina Leidinger on which stereotypes are moderated and under-moderated in search engine auto-completion.
Hi everyone, thanks for being here. My name is Alina Leidinger and I'm very happy to be presenting our work today, which stereotypes are moderated and under-moderated in search engine auto-completion. And this was joint work with Richard Rogers at the University of Amsterdam. For this work, we conducted a large number of stereotype eliciting search queries in 3 search engines, namely Google, Yahoo, and DuckDuckGo. So you can see an example there on the left-hand side, for instance. We took all the social groups we considered from previous work. So this is the auto-completion that you would get from Google. But if we look at Yahoo, for instance, the picture can look actually quite different. So this example already shows us how content moderation policy can really differ between different search engines when it comes to stereotypes. The stakes of perpetuating stereotypes have been pointed out again and again in previous work. So stereotypes are known to frame and distort how we see the world. Safia Noble has laid out how stereotypical and racist results perpetuate oppressive social relationships. And stereotyping, and particularly stereotyping through search engine products, reinforces stereotypes in the real world, for instance, in professional contexts, and leads to change in epistemic actions that can be harmful. So for this work, we looked at these three search engines, namely Google, Yahoo, and DuckDuckGo. This was before Bing and the Bing and ChatGPT news, so unfortunately that was not included. So what do we know actually when it comes to the auto-completion moderation in these engines? So Google details that they prevent policy-violating predictions. In particular, they remove results after they've been reported by users. They remove adjacent results as well through pattern matching. Yahoo is somewhat more permissive in their content moderation. So they remove hateful results rather than offensive speech. When it comes to Yahoo, we don't really have any official documentation, but we know from press reports that they remove offensive returns. And they license their auto-completions from Yahoo. In this work, we looked at the following research questions. So overall, for which social groups are auto-completions moderated? And when there are auto-completions, are they particularly negative? And can we say that certain engines are stricter or more permissive in their moderation than others? To conduct the study, we prompted free search engines to elicit stereotypes. So for instance, we used the query, why are, for example, old women so? A query that implicitly assumes that the person asking is aware of the stereotype, at least. We looked at around 150 social groups that broadly fell into the categories age, gender, nationalities, peoples and ethnicities, political, politicized, religion, and sexual orientation. To collect those social groups, we looked at previous works, for instance, from StereoSet, and remapped them so these categories align with the groups that are under consideration by Google content moderation policy. In analyzing our results, we considered the following three as strong indicators of moderation. So for instance, if we found a query to yield mostly 0 or only 1 autocompletion, if we found that the number of autocompletions were substantially lower in one engine but much higher, for instance, in another, or if common very negative stereotypes were absent from the search results for one engine, from the autocompletion results for one engine, then we considered those as strong indicators of moderation. We operationalized our reasoning via sentiment analysis, so we scored all the autocompletions, gave them negativity scores, and we collected summary statistics in 2 timestamps in 2022. So what were our findings? Sexual orientation as a category overall was heavily moderated by all 3 engines and stood alone in this regard. Religion and the political or politicized category were moderated by Google and by DuckDuckGo, but little by Yahoo, for instance. And the results that we found there actually included anti-Semitic slurs, such as the example on the right-hand side you can see. So in a sense, what we saw for Yahoo much reminded us of the Google autocompletions in around 2016, 2017, before there were a lot of news reports after which autocompletion results were taken down. When it came to the peoples and ethnicities category, those were heavily moderated as well by Google and DuckDuckGo, and very little actually by Yahoo. So we saw the example in the beginning. That was striking. Nationalities were surprisingly moderated by Google. Also a lot of nationalities that you wouldn't commonly consider marginalized. They were partially moderated by DuckDuckGo, and Yahoo, again, presented itself as being quite permissive, so we found very little moderation there. Perhaps most surprisingly in the study was that gender in general is not much moderated, almost at all, you could argue. So we found many stereotypical results for all three engines, actually, that were generally very negative. So 2 examples there for men and for women from Google and DuckDuckGo paint a picture of what we saw. And also age kind of stood alone as, well, was moderated by Google to some extent, but we found a large number of stereotypical results for Yahoo and DuckDuckGo there. I want to end with 3 implications of our research. In general, we found a hierarchy of concern between different groups. So for all search engines, gender and age is really generally an under-moderated category, whereas, for instance, sexual orientation is very thoroughly moderated by all 3 search engines. So here our suggestion would really be to flatten this hierarchy further. Secondly, given that the stakes of perpetuating stereotypes have really been very clearly laid out in the literature, and given that autocompletion is still not an optional service, so you cannot opt out, we wanted to raise the question whether that should really be the case. So given the stakes, should autocompletion be overall not available as a service, or at least be an opt-in, opt-out service? And lastly, we've looked at content moderation, the reports that companies provide us as to what they report. We've read blog posts, but there's not much official documentation. So here we wanted to really call for greater transparency of what is moderated and for evidence of moderation as well. Thank you very much.
Next, we're going to hear from Laura Lukaj on AI regulation is not all you need.
Perfect, yes. Yeah. Hello, everyone. I'm Laura Lukai. I'm a researcher in AI auditing and regulation at the Technical University of Munich and Volkswagen Group, and I'm here to present our paper, Regulation is Not All You Need, in collaboration with Patrick van der Smaakt and Jalal Benbouzid. I would like to apologize because my flight got cancelled and I just arrived before the session, so I hope I make sense. Otherwise, meet me after a coffee, please. So the motivation of this study was really to analyze the current gaps in between the legal requirements that are emerging around many jurisdictions, but the European Union in particular with the AI Act, and the internal practices that must be conducted to really not only provide compliance later on, but really improve the overall quality of the systems that are being developed. So the challenge that we tried to explore was the lack of operational guidance in the current draft of the AI Act, and the lack of comprehensive oversight practices internally for companies to really understand how do their models work, to what extent is it safe to deploy them based on a context. And so we tried to look at this inadequate also governance landscape. So the paper aims to identify the current operational gaps in the legislation proposal and understand and understand which practices can be leveraged to not only provide compliance later on, but improve the overall quality. So in the related work, we really tried to explore the practices emerging in the literature that could be leveraged to address this gap, whether it's from software engineering that could be translated to AI. There are very many helpful safety and security practices such as bug bounties, audit trails, red team exercises to really try to unveil a system's vulnerabilities, but also incident analysis, for example, to really understand when something goes wrong, why such incident happened and how could it be mitigated. Another important practice that emerged in the literature are documentation, whether it's model cards, data sheet for data sets, fact sheets. It's very important to provide compliance later on to have comprehensive documentation throughout the whole life cycle. And currently, the draft of the AI Act talks about legislation, but on a high level, and companies don't really adopt these practices early on, and that is fundamental. We put a particular emphasis on auditing because the legislation talks about conformity assessment practices, but really many of those practices could be part of a life cycle audit. So we really try to look at the literature and and how to further develop the nascent field of auditing. Moreover, it's also important to analyze toolkits because they could be a great introductory tool for companies to get their team members accustomed with problems that could emerge, for example, detecting diversity in data sets or which fairness metrics matter for the context of deployment. So then to understand the gap, we proceeded with a qualitative analysis through semi-structured interviews, and we used the method framework analysis to really understand how these gaps can be addressed and come up with some policy recommendations. So we aim to interview experts coming from different backgrounds to really understand what is being done in academia and the industry to understand such gaps. And we then clustered the findings of the interviews around 4 key main themes that emerged. So the first theme that emerged are the practices that currently the experts we interviewed are further developing or investigating that could be helpful to address such gaps. For example, transparency and explainability to really understand how to provide explainability whilst also preserving intellectual property. Moreover, testing is currently emerging as very important to really shift the mindset in the AI development community and really understand how to adopt red team exercising, for example, from the field of penetration testing to AI. And accountability, which is fundamental to really provide detailed documentation of roles and responsibilities throughout the whole life cycle. The second theme that emerged are the operational issues in the AI Act that the experts worry about and really need guidance into translating into operational practices. So, for example, there are many issues around the risk classification of the current draft and really understanding on which risk category a system falls upon is fundamental to develop then the conformity assessment practices. Another issue is the intersection with other legislations to really understand what needs to be done to be compliant in different jurisdictions and with different European laws also, for example, to the AI Act specifically. Moreover, it's important to understand that when the legislation draft has a high-level language, it's very complicated to provide enforcement and legal certainty because it could turn into a checklist legislation. So it's very important to mandate certain practices. Another theme that emerged is the disadvantage for SMEs, because currently there is a lack of comprehensive methodology to address auditing, conformity assessment, and that will be very costly later on once the legislation is enforced for SMEs that don't have the personnel to address such novel fields. And another very important theme that emerged is the lack of technical expertise in the EU legislation. And this was clear by the problematic language that emerged. For example, the first version of the AI Act required error-free data, and it was later on modified by error-free to the best extent. And if any of you processes data knows that that's a bit challenging. So even understanding how to provide clear technical terminology to address these issues is important. Oh, sorry. And the third theme that emerged are the technically feasible practices that could be leveraged to really translate these legal requirements into actionable practices to improve also the quality. So documentation practices emerged among many experts as a fundamental practice that is not widely adopted, unfortunately, and the same for auditing. Although most of the experts agreed the important role that auditing will play in the conformity assessment requirements, it's still a very novel field, and there are not many audit frameworks that can be adopted internally out there. Moreover, assurance practices are fundamental to provide more transparency into the actions that are being and the claims that are being made about a system. So whether it's about transparency or explainability, there is a need for further documentation into how this was done in practice and not just checking a box of, yes, I took care of explainability. Another important theme is the cross-disciplinary training and collaboration around teams, because it is increasingly more necessary to understand how to translate ethical legal requirements into actionable measures, and this requires a lot of teamwork. The fourth theme we explored were the governance tools and novel policy-making solutions, because with the experts, we saw that the legal uncertainty emerging currently also stems from the problematic top-down approach that the European Union has gone for. So it is necessary to understand that AI is a constantly evolving technology, and so it requires also novel ways of policy making and really understanding how to collaborate with the private sector to really understand how the legislation could be implemented internally and how it could be improved, the ecosystem, by really collaborating, whether it is in policy prototyping experiments or regulatory sandboxes, where you test the legislation in an environment and understand how it could be, how to comply with it in practice, and provide feedback to the legislators into the technically feasible measures and the problematic language that cannot be translated to practice. Or whether it's by having harmonized standards and accredited certification, which is currently missing in the ecosystem and really provides the lack of then efficient internal and external oversight mechanisms. So overall, I'd like to discuss these four main themes by really mentioning that while we explored this field, we really saw the lack of holistic methodologies throughout the life cycle to really understand how such systems work. And I really think this is a fundamental shift in AI mindset, because in other fields, such as medical field or aviation, there is not the same mindset. There is extensive testing to understand how things should work. And as upset I was about the plane that got canceled, I was really happy that they have this extensive testing to really understand that they know that something might go wrong, and they don't just, launch it there on the market. So well done, aviation. The second main finding for me was really the necessity to mandate actionable practices in the legislation also. I know that the law has to stay interpretable, but it's fundamental to have a technical, feasible language in the requirements to really incentivize the adoption of the right measures. Otherwise, it could still lead to a checklist legislation and really the lack of adoption of proper oversight mechanisms. Another finding was for us the infancy of the AI auditing field, because unfortunately, even though most of the experts recognize its key role into the translation of the legal requirements into internal practices for conformity assessment, it's still very novel, and it's a worthwhile endeavor for sure to advance the field. And the fourth finding was really the need for these novel governance tools, because in the legislation it's clear that whether there is a collaboration with businesses, still there is a gap into the influence of the legislator having enough knowledge on how these requirements could be applied in practice. And that is fundamental to make sure that the AI Act is adopted in Europe seriously and the mindset shifts. So overall, we came out with 3 policy recommendations. So hopefully the mindset of auditing will change, and there's going to be really the necessity to mandate audits to really incentivize the development of the nation field, because it could provide a comprehensive accountability throughout the life cycle of an AI system. There is a tremendous need for including technical expertise in public institutions, really, because it's hard for European public institutions to compete with big tech, of course, and that is one of the main problems. But it is necessary to really try to include the opinions of technical experts that know how things work in practice and what is doable and what not, to have a better applicable presentation. Oh, sorry. And then the third policy recommendation is the need to develop a credit certification and harmonized standards. So currently, the field lacks of these 2 fundamental governance elements that could really help solve some of the gray zones into the internal practices that need to be adopted. And hopefully, we will see that emerging soon and not 5 years after enforcement. So thank you for bearing with me. And if you have any questions, I'd be really happy to answer them per email, which unfortunately is not there. So thank you. Thank you so much.
For the final talk, we'll be hearing Examining Risks of Racial Biases in NLP Tools for Child Protective Services from Anjali Field. And we'll have time for questions on all the talks afterwards.
Good afternoon, everyone. My name is Anjali, and I'm presenting our work on NLP tools for Child Protective Services. As I'm sure everyone in this room has heard, NLP models are liable to perpetuate bias. However, at least in NLP research, a lot of times these evaluations are conducted on synthetic data sets that are designed for probing models and not necessarily reflective of deployed context or direct harms. However, practitioners are actively deploying and considering deploying these models in real high-stakes settings. In this work, we focus on one such setting, Child Protective Services. CPS agencies are actively looking to deploy NLP tools to process copious amounts of text data that they have logging communication with families. This data is often too numerous to review manually, and processing it can contribute to caseworker turnover and burnout. So there is an idea that NLP might be useful in this setting. However, NLP models are known to exacerbate existing data biases, and there's well-documented racial bias in CPS settings. As a couple of examples, Black children are more likely than white children to be reported by doctors for abuse, even with similar injuries. When they are referred to CPS services, the referrals are screened in at higher rates. And in the state where the data that we're working with comes from, Black children are placed in foster care at higher rates. So the central question that we ask in this work is if deploying NLP models in CPS settings is liable to increase the bias against Black families. I'm going to start by describing the raw data set, and then I'll talk about the two different types of NLP models that we examine. This data that we work with is a set of 3 million contact notes that were shared with our research team by one Department of Human Services in one county who asked to remain anonymous in this presentation. The data was shared with us under a data sharing agreement and IRB-approved protocol and was stored on a secure, dedicated, encrypted server. Since we're focusing on racial bias, I'm going to take a moment to talk a little bit about how we define race in this setting. The main data that we draw from for race is individual records that are inputted by CPS workers, so this means that we do discard data where race wasn't recorded. We also focus specifically on Black and white families and children, and while this is clearly a simplification in the county where our data is from, this does reflect the majority of the data. And finally, when we consider case or referral level analyses, as cases and referrals involve multiple people, we consider a case or referral to be about a Black family if at least 50% of the associated people are Black, and similarly for white families. When we just look at the data itself, we do find differences in which terminology is used in notes describing families of different races. So for example, in notes associated with Black families, they tend to refer more to basic needs, while notes about white families tend to refer more to substance abuse. We also find some other differences that are likely more reflective of the style of note writers and the sources that they interview, rather than necessarily events that actually happened. Because we do find some differences in the language used in these notes, that suggests that we have reason to believe we might also find differences in how any models that are trained or deployed over this data might perform. And we investigate two different types of these kinds of models. The first one that we look at is an existing risk assessment tool. To provide a little bit of background, in the county that we work with, a case typically begins with a referral where, for instance, someone calls a hotline with concerns about a child. Call screening staff then determine whether or not the referral needs to be investigated, and one of the possible things that can happen if the referral is investigated is through a court order the child could be removed from their home. The county currently uses a risk assessment tool that shows call screening staff a predicted risk score that is based on a model trained to predict if a child will be placed out of home given that a referral is screened in for investigation. And this model is currently trained using tabular structured data, including things like past services. What we investigate is if we incorporate text features into this model, does that increase model performance disparities for Black and white children? And I'm skipping over the details of how the model is implemented here, but you can find them in our paper. When we do add text features to the model, the overall difference in model performance is fairly small. But one of the direct possible harms that we investigate is if incorporating text features might increase the number of Black families that are flagged as high risk by the model. And under the model without text features, we do see that a higher percentage of Black children are flagged as high risk. But when we incorporate text features, we don't see that this disparity is increased. We actually see that it's a little bit decreased. We look at a number of other metrics in the paper, but the high-level summary is that we don't find evidence that incorporating text features increases racial disparities in this particular setting. The second category of models that we examine are information extraction tools. And we start with named entity recognition. The task of named entity recognition involves identifying spans of text that refer to things by name, and in this case, what we focus on is people. One potential use case in ways agencies are considering deploying this type of technology is in the event that a child is removed from their home, caseworkers might be able to search through notes to find people who could be potential guardians for the child. We look at 4 different NER models, and we investigate their performance over full names, first names, and in notes about cases and notes about referrals. And across all of these conditions, we find that the models have significantly higher recall in identifying names of white people than Black people. What this suggests is that if hypothetically caseworkers relied on an NER model to identify kinship placement options for children, because any imperfections in recall potentially represent a missed opportunity to find a kinship placement home for a child, and because we find that these models have lower recall for names of Black people than white people, this suggests that deploying this technology for this use case could result in more Black children being unnecessarily placed in group or non-kinship homes. The final model that we look at is co-reference resolution. And the task of co-reference resolution involves both identifying entities that are mentioned in text and linking them together if they refer to the same thing. What we focus on here is a schema that we adopt from medical note processing that involves identifying mentions of people, problems, treatments, and test entities. And some example ways that agencies are considering deploying these technology is for the purpose of tracking progress, treatment, and problems of a family or individual over time, as well as identifying cases for supervisory review. What we find is, and I will add a little disclaimer here that our data set here is small, but what we see is when we take a co-reference resolution model that's trained on out-of-domain data, and evaluate its performance on data in CPS settings, we see that the model has a significantly higher recall, it's not significant, but has a higher recall of problem entities for Black families than for white families. When we fine-tune this model on a data set of notes in this setting that are annotated for this task, we still find that the model has a higher recall of problem entities for Black families, but that the model also has a higher recall of treatment entities for white families. So what this suggests is that if these models were deployed in this context, this could result in unfairly increasing the scrutiny of Black families. Overall, what our work focuses on is examining the risks of racial bias in realistic deployment settings for NLP models. We find significant evidence of racial bias in NER models, possible potential biases in co-reference resolution, and no evidence of increased racial bias in risk assessment. There is already a lot of existing critique of risk assessment tool, but what our work suggests is that even though information extraction tools seem more benign, they can still result in direct harms. In our paper, we additionally have much further discussion on other risks that could be involved in the deployment of these models. For instance, how they can reduce privacy, reduce transparency, or reinforce existing power imbalances by giving more tools to caseworkers and agencies and not necessarily directly to families. And I'll end by thanking the people and agencies that supported this work, and you can find more details in our paper.
Now we're going to get all the authors to come back up, and maybe people can line up at the mic if they have any questions. Just kidding, we don't have time for questions. You can find the authors afterwards. or hop in.